A series defined as follows. You have the sum from n equals 1 to infinity, negative 1 to the nth power times n factorial over 1 times 3 times 5 all the way up to 2n plus 1. Determine the convergence or divergence of the above series using the ratio test. So let's take the limit as n approaches infinity. We're looking at the absolute value of the n plus first term so plug in n plus 1 in for n, and then we're going to divide this by the nth term. Now a lot of things are going to cancel, but in order to see that, it's better to rewrite this, and we're going to write basically these two go together, and then these two will go together as a fraction. So basically we have negative 1 to the n plus 1 times n plus 1 factorial over negative 1 to the nth times n factorial. Then multiply that by 1 times 3 times 5 all the way up to 2n plus 1. And then the bottom will be all the way up to 2n plus 3. So now there's going to be some things canceling. First, we have n plus 1 factorial over n factorial. That's just going to be n plus 1. The negative 1 to the n plus 1 over negative 1 to the n would just be negative 1. But because you have an absolute value, that's just going to be positive 1. So I could just ignore that. So from the first fraction, we have n plus 1 left. The second fraction, 1, 3's, 5's, all the way up to the 2n plus 1 are going to cancel. And I'm left with 2n plus 3 in the denominator. So we have the absolute value of n plus 1 over 2n plus 3. Really here I don't need the absolute value anymore, so I can delete that. And so now when we take the limit, okay, well, one way is to divide everything by n. We have 1 plus 1 over n over 2 plus 3 over n, and then as n approaches infinity, this goes to 0, this also goes to 0, and you have 1/2. And because this is less than 1, this series converges by the ratio test.